Hi, physical science students. Today I'm going to do the practice sheet on the balanced and unbalanced forces. This is from the first worksheet that we did of this unit. And basically what you're doing is looking at diagrams and determining how are the forces working together here. So for this first one, we have an object that's at rest originally. And we've got four forces. We've got 10 newtons going up, 10 newtons going to the right, 10 newtons going down, 10 newtons going to the left. And so we want to first find what is the net horizontal force. So horizontal, again, that's side to side. And so we have 10 newtons right, 10 newtons left. And so I'm going to subtract those two forces because things going in the opposite direction get subtracted. 10 minus 10 is 0 newtons. There is no force in the horizontal direction. Therefore, those forces are balanced. And what, if anything, does this do to the object's horizontal motion? Nothing. All right, in the vertical direction, we have 10 and 10 again. So you can bet that we're going to get the same answers here. 10 minus 10 equals 0. These forces are balanced. And again, nothing will happen to that object. It's an object at rest. It will stay at rest because no net force acted on it. All right, let's move on to the next one. Number 2, we have an object that is at rest again. And now the net horizontal force. Well, let's look at what forces we have in the horizontal direction here. We've got 15 going to the right, 10 going to the left. So I'm going to go 15 newtons minus 10 equals 5 newtons to the right. So we have a net force of 5 newtons to the right. These two forces are unbalanced. And what, if anything, will happen here? This object will accelerate to the right. Acceleration of an object is always in the direction of the net force on that object. All right, the next one, net vertical force. Here we've got 10 and 10. So that's 10 newtons minus 10 newtons equals 0 newtons. Just like we had in the previous problem, these forces are balanced, and in the vertical direction, nothing's going to happen. This would be like pushing a book along the table. The weight of the book down, the normal force from the table on the book up, don't allow the book to move up and down, but if you push on that book, there's going to be some friction coming back, and then you're overcoming that friction while you're pushing it. All right, next up, we have an object that is, again, at rest originally. Our horizontal forces this time, we've got 10 and 10 again, so those are going to be balanced. I'll just show that by going 10 minus 10 equals 0. Circle balanced. What, if anything, happens here? Nothing in the horizontal direction. In the vertical direction now, we have 17 minus 12. 17 up, 12 down, and again, those are obviously unbalanced because they're not the same. And when I subtract them, I get 5 newtons. That's a 5 newton upward force, net force, and that means the object is going to accelerate upward. All right, moving on to number 4. The object is at rest originally, and now, if we look in our horizontal direction, we have 17 to the right, 10 to the left. So that's going to be 17 minus 10 equals 7 newtons. And those are obviously unbalanced again, and we're going to have an acceleration to the right. In the vertical direction, we have 17 and 12. So 17 newtons minus 12 newtons equals 5 newtons. Again, unbalanced forces. We're going to get an acceleration upward. And then we have a last question here. What do you think the overall motion of this object would be like? And again, we know that we're going to have an acceleration up, we're going to have an acceleration to the right, but it can't go in both of those directions. So these two forces are going to combine into one net force. And if this is north and this is east, then this would be northeast. We don't really have those kind of directions in the problem, but you can say, or you could say it's accelerating up and to the right. All right, let's move on to the second page. All of those objects were objects that were starting at rest. Now we have objects that are moving at a constant speed to the right before these forces are applied. So this first one looks exactly like the one that we started with. However, I'll put a few motion lines on there. This object's sliding to the right now at a constant speed. So in the horizontal direction, though, we have a 10 Newton force and a 10 Newton force. So that's going to be 10 minus 10 again. That equals 0. Those forces are balanced. And again, nothing's going to happen. Vertical direction, we have 10 and 10. So that's going to be 10 newtons minus 10 newtons equals 0. Again, balanced. And nothing will happen. Not very interesting. So the object isn't going to stop moving because there are no forces. It's actually going to just keep on moving with that constant speed, whatever that constant speed was before people started trying to push on it. All right, let's move on to the next one. Now we have the same object moving at a constant speed to the right, and in the horizontal direction we have 10 newtons and 15 newtons. So let's subtract those, and we get 5 newtons. Those forces obviously unbalanced because they're not the same, and this object is going to accelerate to the right. So if it was going at 5 meters per second, now it's going to start climbing. 6, 7, 8, 9, however much mass it has will determine how much it's going to accelerate here. The net vertical force, 10 and 10, so again, nothing happening in that direction. All right, moving on to number 7. Now in the horizontal direction, now this is kind of a change. For the first time we have a force to the left that's bigger than a force to the right. And I'm still going to subtract. I'll go 17 newtons minus 10 newtons here. Those are my horizontal forces. And I'm going to end up with 7 newtons, but the winning force is the one going to the left, and the object is moving to the right. So this means that, first of all, they are unbalanced forces. I'm going to have an acceleration to the left, and if I have acceleration to the left, but my velocity is to the right, that means that this object is going to slow down. And that's the way, that's an illustration of how the brakes on a car work. You're driving along, maybe you're driving at a constant speed, you apply the brakes. The brakes provide a backward force on your car, and that makes the car come to a stop and slow down. In the vertical direction, we have 10 and 10, so we've seen this a number of times, nothing new here. And then finally, number 8. We have an object is already moving at a constant speed. I'll put my little motion lines on, and it's to the right before forces are applied. What do we have? It's the same as we had on the number 4 when the object wasn't moving. So I have 17 newtons minus 10 newtons equals 7 newtons, unbalanced, and this will accelerate right. Vertical direction, 17 newtons, 12 newtons. And so those are unbalanced, and we will accelerate up. And again, it can't go in 2 different directions, so its net acceleration is going to be in this direction, starting at the 5 meters per second it was moving at the beginning. So really, what we're going to see is you would see a motion that goes like that because of its already previous 5 meter or constant speed, whatever that was. All right.